Okay, we're going to continue solving quadratics, but this time we're going to focus on equations that are in squared form or vertex form, okay? So our main strategy is going to be by taking square roots. So how to solve quadratics? Well, number one is you want to get the x squared term, what I call alone, okay? Then step two is you're going to take the root of both sides. And number three, when you take a square root, because when you have something squared, it can be a positive squared or a negative squared, and it's the same answer, your answer is going to be plus and minus that root, okay? So then step four is simplify root if possible. Okay, so some of these are going to be shorter than others, but I have definitely plenty of examples for you to kind of see the difference. So I have 8 examples altogether. So you'll notice the first few get longer as you go, and then the last 2 have parentheses. Okay. So I would recommend watching all 8, or at least fast forwarding to see a few of the different styles. Let's look at my first example. The only directions are going to say solve, and notice I try to change the letters up because the letter isn't really important. It's still a variable. So on my first example, you've got n squared. So I want to get the x squared term alone, and there's no numbers that are by the n squared. So step 1 is done. So now the inverse operation of squared is square root. That's why we do it. So square root and squared, they actually cancel each other out. So on the left side, you just get n, and then because I took a square root, I get plus and minus 45, okay? Now, we need to try to simplify that. So remember, for square roots, you want to look for doubles, okay? I don't want a decimal, I want the exact answer. So we're going to find 2 numbers that multiply to give us 45. So I think 9 times 5, okay? And you want to keep breaking that down until it's done. So 9 breaks down into 3 times 3. So here's a double. I'm going to circle it, and it goes out in front. We write it once with the plus and minus. The 5 is single, so it's going to stay in the root. So really, my 2 answers are positive 3 root 5 and negative 3 root 5. We can just write them together. Okay, so let's look at my second example. Same idea. We've got x squared equals 81. The x squared term is alone, so I can start by taking the root. Root and squared are inverses, so they cancel. So x equals plus and minus root 81. So I need to come up with 2 numbers that divide into 81. So some of you might know it's 9 times 9. Well, remember, I'm looking for doubles. So even if I can break that down, I don't have to. So I'm going to circle these 2 doubles. And it comes out in front. You write it once. There's no singles left, which means there's no root. So really, what we know is that my answer is positive 9, and we know it's negative 9. And think of that. If I do 9 squared, do I get 81? And if I do negative 9 and I square it with parentheses, I also get 81. And so that's why we have 2 answers. Sometimes it's easier to see when you don't have a root, but that's why number 1 was also plus and minus. All right, let's look at number 3. Well, here's my p squared, but now I have a 7 next to it. Since those are being multiplied, I'm going to divide both sides by 7. You have to get the squared alone first. If you take the root, your answer won't be correct. So the 7's reduce. I get p squared equals negative 8. Okay, so now I've got p squared. So I'm going to take the root of both sides. So root and squared cancel. I get p equals plus and minus root negative 8. Now, back in quarter 1, we saw that we can have a negative under a root, and it gave us an imaginary number. So if you're new this quarter or forgot that idea, we're going to bring that back and review it, okay? So what I can really do is I can split this up into -1 times 8. And it's like these are both roots, okay? And the -1, remember, the square root of -1 by definition is I. The 8 I want to break down. So 4 times 2, and then break the 4 down, 2 times 2. So here's a double, and here's a single. So what that means is my final answer is plus and minus. I have a 2 double, so the 2 comes out. I have an I, and then this single 2 stays in the root. So our final answer is plus and minus 2i root 2. So if you try typing that in on a calculator, the square root of -8, it probably says error. You're going to have to do negative square roots by hand, okay? But I kind of show you how to do all of it by hand. All right, fourth example. Here's my b squared. So that means I have to move the 4, and we have to move this -4. So when you solve, you always want to do the adding or subtracting first. So we're going to do the opposite and add 4. So 4b squared equals 36. Then these are being multiplied, so I'll divide by that 4 on both sides. So b squared equals 9. Our next step, since it's b squared, is to take the root. So b equals, and then plus and minus root 9. Well, the square root of 9, remember, it's 3 times 3. So some of you might just know that it's 3, and that's fine. So we actually get plus and minus 3, because there's my double. All right, let's try more. So I want to get p squared alone, so we're going to have to move the 36 and the 10. So we're going to do the subtract 10 first. So 36p squared equals 64. Then these are being multiplied, so I'm going to divide. So p squared. Now, 64 divided by 36, that's not an even number, but what I can do is I know that 64 is 8 times 8, and 36 is 6 times 6. So even though I can reduce those, I'm going to leave them alone for right now. Sometimes you do want to reduce to help, but I think this time it actually makes it easier if we don't. So I just did this over here. The square root, this is like the square root of 64, and we can do the square root of 36. We learned that back in quarter 1. When you have roots being divided, you can think of them separately, and it's plus and minus, okay? So p equals plus and minus. Well, the square root of 64 is 8, because those are doubles, and the square root of 36 is 6. And there's no singles, so it's just 8 over 6. And then these both reduce, divide by 2. So we get plus and minus 4 over 3. Okay? That was I would say, a medium level of difficulty. That was pretty long. All right, let's look at our next problem. Well, here's x squared. I want to move the 4 and the 8. So we're going to add 8. So 4x squared equals -62. All right, these are being multiplied, so we'll divide by 4. So x squared equals negative, and then I get 1. You can use a calculator to do this. So it goes in 1 time, and not nice. So I'm actually going to, let's erase this. Since it's not even, I'm just going to reduce this. So if I divide this by 2 and divide this by 2, I get -31 over 2. So now, because this is x squared, I'm going to take the square root of both sides. So the square root and x cancel. We get x equals plus and minus. And then I have negative 31 over 2. I don't want to change that into a decimal. And I can think of that as negative 31 over root 2, because I can think of them separately. So now we have a dilemma. Well, 31 doesn't break down, and 2 doesn't break down, and they don't divide into each other. So you have two things we need to get rid of. This negative, which remember, I can just bring an I on the outside. And then back in quarter 1, we learned about rationalizing. So we're not allowed to leave a root in the denominator. So I'm going to, I call it move it up and out, because I'm going to multiply by root 2 on both sides, top and bottom. And what happens is I'm going to multiply these together. So I get plus and minus, I have the I. And then 31 times 2 is 62. And then root 2 times root 2 is root 4, which is 2. That, though, is out of the root. So see, that's why I said we really move the root up in our answer, and then we take the root off. So it's move it up and take it out for our answer. That's about as hard as those get. So the first row, I'd say easy, easy, medium, 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 hard. Level of difficulty. So now we're going to have problems that have parentheses. So order of operations, remember, you always want to treat the parenthesis on the outside. So we're going to try to get the parenthesis alone. So on this problem, it is alone, which means I can start by taking the root of both sides, because the root and the squared on the outside cancel. So you're just left with what's on the inside. And since nothing else is there, like the squared, I don't need the parenthesis. I took a square root, so it's plus and minus root 14. Now, we're going to try to break down the root. So 14 is 2 times 7, and that doesn't break down anymore. There aren't any doubles. So what does that mean? That means that I can't simplify the root. So we're going to erase what we tried to break down, and we just have to leave it as root 14. Okay? So now our goal is to get the x alone. So what we want to do is subtract 1. Now, we can't really subtract 1 from a root, but what we can do is put them side by side. So we're going to write 3x equals, and I would just put my number first, negative 1 plus and minus root 14. And then the last step, since the 3 is being multiplied, is to divide everything by 3. So x equals negative 1, and this kind of looks like the quadratic formula, so you can leave your answer. Okay? That's the exact answer. All right. Notice the difference on my next problem. I have numbers by the parentheses where I didn't before. So we do want to get this alone first. So we're going to subtract 1. So 3 parentheses. Okay. I still need to get that parenthesis alone. So the 3 needs to get moved. Since it's being multiplied, we can divide. So x minus 5 equals 7. And now this turns into my last problem. So we are going to take the square root of both sides. So we get x minus 5 equals plus and minus root 7. What's nice though is it's actually nice when the root doesn't break down. So because root 7 is just 7 times 1, there aren't any doubles, we're going to leave this alone. So then I'm going to add 5. But remember, I can't really add 5 to the 7. We just put it next to it. So I've got 5 plus and minus root 7. Okay? All right, so these two examples, the root did not break down. So let's keep going. Well, here's a parenthesis. I need to move this negative 3. So we can divide because it's being multiplied. So we get x plus 2 equals negative 11. Well, since we have a squared, I can take the square root of both sides. X plus 2. And then I have plus and minus. Remember, anytime I had a negative under the root, I'm going to take out an I. So I can do that now. And then I think, well, 11 doesn't break down, so I just need to get x alone. We're going to subtract 2. So x equals -2 plus or minus I root 11. So anytime you have a negative under the root, you can take the negative out by writing an I, and then you just keep the same number inside and try to break it down if you can. All right, we have a parenthesis and then a plus 12, so we need to move the 12. So x minus 6 squared equals -8. Since it's parentheses alone, I can take the square root now. So x minus 6, I get plus and minus. I have a negative under the root, so we take it out with an I, and I leave it as 8. Now, 8 does break down. So 4 times 2, and then 2 times 2. So here's a double, and here's a single. So now I'm going to be able to break that root down again. So I get x minus 6 equals, the 2 is going to come out, so plus or minus 2i. We always put the number in front of the letter. And then this 2 is single, so it's going to stay in. And my last step is I'm going to add 6. But remember, I'm just going to put it side by side. So x equals 6 plus or minus 2i root 2. All right, my last example. I got a lot going on. This is probably going to be the hardest one. So I've got a 7 I have to move and a 5. So we're going to add 5. So 7, 2x plus 1. What is that? 37 plus 5 is 42. We'll divide by 7 because it's being multiplied. We have to get that parenthesis alone. All right, since we had the squared, I'm going to take the square root of both sides. So 2x plus 1 equals plus or minus 6, root 6. Now, since it's not -6, I don't have an I. 6 breaks down into 2 times 3, but there's no doubles. So remember, that means we can't break the root down, but I tried. So I just need to get x alone. So we can subtract 1. So 2x equals -1 plus or minus root 6. And then the last step to get x alone is to divide by 2. And when you divide everything. So x equals -1 plus or minus root 6 divided by 2. All right, these have some work for sure. So on your student practice, you're going to pick some problems to do. Okay, email me if you have any questions.